Hello, hello, hello. Hello, everyone. Good evening. My name is Ravneet. I am the program manager at Reactor London. I wanted to obviously welcome you all back to in-person events. We also have our own community, which is called Microsoft Reactor London, and we do our own events as well as community events. Reactor is a community space. It is for the communities, by the communities, and all the events which take place over here are free to attend, and we also encourage, if you're a speaker, if you run your own community, you can run your events for free at the Reactor, and the events must be open to everyone to attend, and they also must have a tech slant to them. If you have any questions, please do reach out to me. I will be here until 7:30 today. Your fire exits, there's one right behind you on the right, and one right far ahead, just where you came in from. Toilets are also at the end. Help yourself to teas, coffees, and snacks. And with that, I'm now going to hand over to Darshna.
Thanks, Rav. Hello, everyone. Lovely to see you all. Nice to see a few new faces as well. So this is the second Data Science London meetup that we've run in person this year. We are hoping to kind of get more of a consistency with them, and we have the next one on the 6th of July on Deepface. So I run the Data Science London meetup group. If any of you are interested in talking or sharing anything that you have done related to tech or data science, please feel free to reach out to me. And with that, I will hand over to the lovely Magdalena, who has joined us all the way from Tenerife, and she is a data evangelist from Toloka. Thank you.
Thank you. I hope you can hear me now. Yep. So today I'm here to present this topic, how to get good data at scale for an NLP project. So let's get started. I'm going to tell you a bit more about the company I work for. So I work for Toloka. Probably you have never heard about Toloka. So it's a data labeling company, and we label a lot of data for machine learning solutions. And you can see some companies that we work with here. And these are also some industries that we label data for. So really a variety of solutions like search engines, voice assistants, e-commerce solutions, etc. But today specifically, I'm going to talk about different cases for natural language processing. And let me tell you a bit more about myself. So I work as a data evangelist, and my background is in data science. This is what I studied in Edinburgh University. And currently, I work as a data evangelist. I also write towards data science, and I mentor data scientists. And actually, as Dashna had said, I live now in Tenerife, but I used to live here in London. So I moved out around 5 years ago out of London. And today I was preparing a bit for this meetup, and I was browsing through my old meetup.com page, and I found this. And this is a photo that was, this was an event that was organized by Data Science London. And actually I attended it, and this is me on this picture here. So just to show you that maybe one day you guys will share your thoughts here, and I would never think I would. So let's get started. This is our agenda for today. So at the beginning, I'm going to talk a bit more what NLP is and what common tasks we face in NLP. Then we're going to talk about some typical steps in NLP projects. And then I'm going to tell you about crowdsourcing and how it can specifically help with annotation of these NLP cases. I'm going to show you some real-life case studies from the projects. And then I'm going to talk a bit more about automation of such data labeling pipelines. So let's get started. What is NLP? So I found this definition. I don't remember now if it was Wikipedia or something, but I like it because it is one sentence. So ability of a program to process and analyze large amounts of natural language data. let's say this is in essence what NLP is. And it's a very interesting field because it crosses a lot of different areas of knowledge, but mainly linguistics and computer science. So you might meet people in NLP who come from linguistics background, and sometimes you might actually meet some that come from more computer science one. And typical challenges are speech recognition, natural language understanding, and natural language generations, and many more. I want to let you think about it here. What kind of NLP products you know from your everyday life? And I actually put some here as well. But if you take a time and just think if you can add anything to this list, probably you can. I don't know if you guys have, if there is something missing and you can actually take your voice. If you don't, that's fine. But I included chatbots, so search engines. And why search engines? You might not think it's not NLP, but we put a search query, it's natural language, then we have an output. Review summarizer, it's very common to have like a bunch of reviews. You want to get an essence. This is NLP again. Information extractors. What I meant here is like devices when you have like a big chunk of text and you want to get like essential data from there, for example, units or maybe a date when someone was born, etc. Automatic translators. So very common right now, translation of languages, and sentiment analyzers. This is current marketing, very popular as well to use those devices, and many more. I think like this list probably is endless here. And how those products are actually built. So let's start with a bit of a history of NLP. So now we are in this third stage, but how NLP started, it's this first step here in this line right now. And it was rule-based approach. And just to give you an idea how it works, basically we had like usually a linguist, an expert in a language that would write some grammar rules that our system would follow. And that was obviously really hard to maintain. There would be some rules that they missed. It would be just very hard to change anything in the bunch of really big rules. And this is why later on this statistical approach was introduced. And this is pretty much when I joined the NLP world around 2010. This is when I was middle of my university. This is when we got started serious about learning actual things at university. And this is actually when it was really popular to train machine learning algorithms, but it was not neural networks like right now. Basically, a lot of statistical approaches just using kind of word counts, n-gram approaches. So basically you train a model on some data sets, it does some statistics, it learns some statistics, and then you basically do some prediction. And from this, around maybe exactly 2010, this is when this neural approach, deep learning approach started to be super popular in NLP. And this is pretty much what people do now. And obviously it's not exclusive. I know some NLP systems that still use rule-based approach, but they are very limited and they work only for limited cases. Most of the products, and especially products you've seen on the previous page, they require this neural approach to work. And how does it work in practice? So this means that a lot of NLP products are basically neural network products. So they follow kind of traditional machine learning life cycle. So usually people collect data at the beginning, and this is something we're going to talk a lot today. Then there is some kind of a data curation. So you might need to annotate maybe your data more, featurize, etc. This actually leads you to creation of a data set that is then used to train a model. And then we usually evaluate this model. This could actually happen several times because we might have different models that we want to check. And again, the whole process also might actually cycles around. So you might already have a working model, but you need to make it better. So you go back to this beginning of this cycle and start again. So it's a continuous process. This is how normal machine learning product where its life cycle is, and the same is with NLP. And with NLP, what kind of data actually comes into our system? And I could think of three main types of data here. So text, pretty obvious, language, but sometimes actually our data, especially, it's not already in the text form. It has to be actually translated to it. So a lot of NLP systems have to deal with recordings or sometimes with images. If there will be maybe a photo of something written, this text would have to be extracted. So these are usually our inputs. And I wanted to show you some kind of annotation tasks that are popular for NLP. So on the first one, we have an example of someone actually annotating a sentiment. So we give them a piece of text and we ask it if it's positive or negative. In the second case, we have a very similar problem, but we try to do something different. We ask a user what's the intent of the phrase that is captured on the pictures. So these are examples of different classification tasks here. But they are obviously different ones. And I show you here also a very popular NLP task. It's named entity recognition. So basically, we have a text, and we want to extract some important information. In this case, we ask someone to highlight dates, tech terms, and numbers. And basically, they have to annotate those in the text. And then another example is this search query example I actually told you before. We have some query, and we have to decide if it's relevant or not relevant. In here, actually, this is missing, might be missing. Sometimes I have only a picture here, but you might have a product description as well. So something like that would be in a product catalog. So that way you would have text as well to match. Another example would be text transcription. So this is what you can see now. Basically, we have a video, a voice recording, and someone has to transcribe it to text. And I've added another one. This is actually a collection one. So sometimes you don't need to transcribe text, but actually you need to collect them, because maybe you want to train your voice assistant, for example, to recognize a specific phrase. So you need a lot of phrases to be spoken, and basically you need to collect this data. So these are examples of different NLP tasks. And now that I showed you this, I want to tell you what is crowdsourcing. And we can start with this picture. So who should annotate those pictures that we have? And you've seen much more before that I showed you. So traditionally, a lot of this data, especially in the earlier stages of NLP, would be annotated by people working on machine learning team, at least to some extent. I've been annotating my own data, listening to calls and transcribing them, and then giving instructions how to do. And as you can see, this can be expensive. A lot of money that data scientists are paid are actually spent to do this task that maybe not someone very qualified needs to do. And it's usually, and I think this is the worst part. This is really hard to scale, because obviously I could annotate maybe 10 calls that last 1 hour, but I need maybe to annotate hundreds hours of calls, and this is basically impossible for me. And also, so another solution, what people do, obviously, it's not only data scientists. We hire other people into our team to do this kind of recordings. Well, data annotation, again, it's not always the best. It kind of works for a while, but with machine learning systems, your data and your systems change a lot. So suddenly you might need more data because something is not working, and maybe you need different type of data. And obviously, in order to scale your team, you need to hire more people. So it is actually really hard to scale. And in contrast, there is a crowdsourcing approach that can be a solution to this problem. So what is crowdsourcing? It's basically having a big task and splitting it into smaller tasks and distributing those tasks to a cloud of performers, and then collecting them together and collecting the results. Very kind of a simple definition of crowdsourcing here. And how it can work in practice. So Toloka, the company I work for, is actually a crowdsourcing platform. And how it works is that you have a platform where researchers, machine learning engineers can post those tasks that needs to be labeled. And then on the other side, we have a crowd that actually can complete those tasks in exchange of money. So just to give you an example, as we were using recordings, I need to gather data, transcribe data, 1 hour call. I can maybe split it into small sentences and send each sentence to a different person, pay them a couple, I don't know, maybe 50 cents, depending how much time it's required for them to complete it. And then I can aggregate those results together and have like a final solution. So this is how such a platform works. And it's usually very important, especially for NLP, that people who work for you, so your crowd, are distributed in different countries. And also for NLP problems, it's really important that they speak different languages. So again, if you want to build a chatbot in English, you need English speakers. But if you want any other language, you need those people basically who speak those languages. And I think a lot of research in NLP has been done in English. And actually, I did only work with NLP in English. But I know there is so much demand, and that some tasks that we actually almost solved in English, basically, they don't have a solution in other languages. So I think this is a very important remark here. And just to tell you how this crowdsourcing and NLP data collection works is if you have access to crowdsourcing platform, to this crowd all over the world, your data collection task basically changes into these 4 different steps. So first of all, you have to choose the crowd. So I might choose only people that speak certain language, or maybe have a certain age because I have an age-specific task to do, etc. Very important in crowdsourcing, I need to train my crowd. So what does it mean? I don't have to give them certificates or anything like this, but basically I need to somehow evaluate if they understand what I'm doing. So for example, again, with the speech in the audio transcription, imagine that there is noise in the background. And this is actually something I work with. There is noise in the background. Should annotator annotate it or not? This is something you have to train your crowd, tell them, and check if they understand these instructions. So very important part. And then we have control quality. This is something, again, I think very, maybe not only to crowdsourcing, but it's in data collection in general. Again, I don't want to manually check all these audio transcripts. I cannot go through it. I have to have some quality measures that ensure that the data I'm collecting is the right data, that basically they're not lying to me and just putting some random words there or anything like this. And then the last step is getting the results. So obviously, if you send something to several people, you need to somehow aggregate it together. Additionally, to be more confident in crowdsourcing, we send the same task to a couple of people. So then we can use some kind of majority voting on something like this. Basically, if more people say that something has this particular label, I believe them more than one person only. This is the idea. And okay, that was a bit of a theory. So let's have a look at some case studies here. And the case study actually comes from the audio transcription. So voice assistants, super popular. I think probably everybody here interacted with one already. I think when we have here Amazon Alexa, I don't know what the other one are actually, but they are different voice assistants. And I'll give you some time to think right now. So what kind of data you think you need to collect to train a voice assistant, your own one, if you want to actually build such a system? And think about it. And actually, we're gonna, it's not a simple answer, because we're gonna now go through several steps and several different tasks that are needed for this. But a lot of people might think, why do I even need to train voice assistant? They are, I don't know if any of you are from actually NLP background, but have you heard of GPT-3? Yeah, so this is a language model that pretty much does magic right now in NLP. And it's been trained on massive amount of data, and it's mainly used for natural language generations. And it actually generates not like it generates sentences, and they really look human, like if human was writing those sentences. It is actually really good, but it's not super relevant to speech technologies. So it's really good for text generation, but for stuff like maybe speech recognition, it's not a direct application of this model. And I know there are some solutions built on it, but it's not the purpose of it. And another thing is, in order to maybe work in your own domain, you need to fine-tune those models. And what does it mean? That you need actually to gather your own data anyway. So let's start with data for the chatbots. Usually it will be recording. We're gonna consider the chatbots you've seen. So actually it is a recording. And as I said, they are different tasks they have to solve. So where I can at least see three here. So first is the intent. When you communicate, we say, hey, Siri, turn off. We actually have an intent. So they have to grab what is it. Then a lot of the time, we need to actually, this text to be transcribed into written text. So this is basically the tradition of the transcription thing. And then you might need to extract some features. So let's say if I said, Siri, play Rihanna, we need to know that Rihanna is actually the singer here. So it needs to extract some features. So those are different types of NLP tasks that you have to deal with. And I want to focus especially on the transcription one, because we have a good case study for this one that we've done. So basically, we have a recording and we want to have a written text. And I added a user interface that actually someone completing such a task could see. So they have a recording which they can play and stop. And then they have a box when they have to write the text. So imagine that I send this type of task, many sentences, to different people. And this is how I will collect data for machine learning model. And I wanted just to show you that once actually you design the crowdsourcing task, I'm not going to repeat myself, you kind of follow these 4 different steps. And we're going to actually see these steps in a more formal pipeline that I'm going to show you later on. Actually, kind of these steps are translated here for this type of projects, and they would be like this. We need to write CRIL instructions and interface. So this is something you've seen. If somehow I messed up my interface and the user can only play the recording but cannot stop, like it goes all the way to the end, it's probably not the best design, because if he didn't hear something well, he can't stop and he have to re-listen it all again. So there are a lot of details you have to think in your design. Another thing that is very important here is to have short audio. No one is gonna listen to 1 hour and transcribe it. So I think probably the good rule of thumb would be 1 sentence. Usually 1 sentence is enough, so they capture the context. Like it would be very different if you do it word by word, but it's not so long that the user cannot do it. And another trick, if you actually gonna design such a system, is to use ASR and typo help. So what we do, instead of giving him a blank box, we run some automatic speech recognition system. There is many available right now. And basically, instead of transcribing the text, he almost corrects it if it's right. And this basically saves time and typing. So people like it more. And then another thing is to use dynamic overlap. So as I said, how do you know that your person is doing it right? Maybe if more people do it at the same time and they kind of do it in the same way, this is when they do it correctly. And I'm going to actually show it on the next slide a bit more. So this is the more formalized pipeline where we have this training and selection. I could design it. And then I have different tasks, transcribe audio tasks that I send it to many people. And I decided that I want to get K exact matches. So actually my threshold could be pretty low. It could be actually 2, depending on what kind of quality data I need. But if I get the K exact matches, I might be pretty sure, hey, I think those 2 guys, if they said the same, well, I don't think they're cheating. Like it would be very, very hard that actually they put 2 random things, the same sentences, for example. So this is how you could design your pipeline. And once you actually have K exact matches, you actually have your transcription. So this is how you could collect this kind of data. And then how do we aggregate this type of labels? So as I said, this is something really hard because, okay, we have K exact matches, but there are some people who actually did a really good job, but maybe missed 1 word or just mistranscribed 1 word. So this is kind of a really hard area here. And I think what we did is the K exact number of matches worked for us. But there's actually another thing that you want to control, and this is quality. So if someone already is doing bad job, maybe I don't want him to work on my project anymore. So even though, okay, I'm not getting his results, but I won't actually block him to actually take part in any of the projects I do. So how do I even know who is a good worker and who is not a good worker here? So again, in traditional machine learning, classification tasks, things like recon precision accuracy work pretty well. But actually for NLP, not really, because you basically compare text to text. There's not something that's specific. So in NLP, we have a special metrics, and those are blue, metal, rouge. Probably they are more, and word error rate as well. And this last one is actually pretty simple. So I wanted to show you how it works. This is basically the equation for the word error rate. So imagine that you have a gold standard. You have 100 sentences, but 10 of these sentences you transcribed yourself. You know they are correct. This is your gold standard. So you can compute word error rate. So basically, this is just a number of mistakes divided by number of the words that needs to be transcribed. Very simple. And the mistakes that someone can do are also very simple to understand. There is substitution. So basically, someone subscribes something like news instead of moose. Yeah. So a small mistake, but important. Then there's a deletion. So there was a word, but someone did not write it down. And then there's insertion. So the word that someone actually write, it was not in the original recording. And by this, you could maybe, this is something that it's a percentage. So the higher number, the worse your performers are doing. So you could try to compute something like this, and this is how you could actually control quality on your project. And there is actually another alternative, and this might be cheating or not cheating. So we actually started with the fact that we already have a recording, and we need it to be transcribed. But actually, imagine you don't have recordings. So that way, actually, you could give a text to someone and tell them to read it. That way, you don't actually even worry about like transcription. So it's basically, it becomes an audio correction task. And it is actually simple because you just tell them the phrase they have to say, and they have to record themselves. Again, similar problems, quality control in such projects, but it's just another way of doing it that could be good for NLP projects. And this is actually a pipeline we did because we work on such a bot. And so imagine you want to collect the Hey Siri recordings. Actually, I forgot about one important thing. Usually in such projects, we add a validation project. And this is actually what this picture shows. So we have a first project that actually would tell people, hey, say this phrase, hey Siri. But we don't know, again, if it's right or not. So we create another project, a crowdsourcing project, where someone has to play this recording and say if this is the same, if this is the phrase that they're saying is correct. If it passes this pipeline, we actually have our data annotated. So this is another way. And let's continue with the chatbots. As I said, there are many things, NLP problems that need to be solved. And one of the problems is actually the bot recognizing the orders. So basically, if we tell them to do something, they need to get the intent. And another one is quality control of communication. So I want my bot to be funny, natural, things like this. So I don't have a specific intent, but it should kind of behave maybe human-like a bit. And this is why usually what we do, we train those models, we create separate projects for each of those tasks. So we actually work on the model called Alisa, and Alisa was trained on kind of different projects. There will be politeness, correctness, child safety, and then we also trained it on the dialogue phase, where actually we would ask people if it sounds natural, informative, etc. And this is the pipeline we kind of have been doing. So the input is the dialogue with the assistant, and then we have different projects where we ask a particular thing, if the particular thing is fulfilled here, and then we gather the results. And again, this is a classification problem. One could think it's a much easier problem that we've been solving before, the transcription one. But again here, very important thing to repeat is clear instructions and interface. And especially here, decomposing the task is important. If I give somehow a dialogue to someone and I say, is it good? Probably I'm not gonna get good answers. I should ask very specific questions. So exactly, is this grammatically correct? Maybe could be one question. Another one, is it child safe, etc. So often we need to actually identify the particular things we want to learn and put them on separate projects. We also need to do control tasks, and this is much easier here. So if I know that some content is not child safe, I can basically mark a couple of instances myself, and I can just see if my annotators are doing it correctly. So actually control here, it's pretty easy, not like before. And then overlap and aggregation. So I always recommended sending it to minimum 3 different people. So you can use majority vote or some more sophisticated algorithm to aggregate the results later. And another thing that we've been experimenting is a sense of humor. So basically, we took some jokes online and we wanted to ask people if those jokes are funny. And this is a very hard task because the humor is subjective. So not all the people will find the same joke funny or not. And we don't have ground truth exactly because of the same reason. It's an opinion, it's not a fact. But that's why we experimented, and we actually, okay, this is actually how the setup looked like. We had 30 dialogue jokes from different sources, 300 participants, and we put it on the crowdsourcing platform. This is how it looked like. So we had a joke, which was a question and answer. Let's read actually one of them, the last one, because it's shorter. What is orange and sounds like a parrot? A carrot. I don't know if it's funny or not, but you could actually, you can see that there is a scale that you can choose from. Not funny at all, can be better, funny, hilarious. So this is what we sent to, we had 30 different jokes and 300 participants. So I believe each must have been sent to 10 people. So crowdsource, and this is what we actually have found out, that it worked and we could actually use it. So if we want to train our chatbot to be funny, we could use this kind of evaluation here. But there are actually some downsides, something like age, language proficiency, and gender. They influence joke ratings. So depending on their background, they would actually find it more funny or less funny. And jokes degrade over time. So basically, if someone already heard this joke, it might not be funny for them anymore. So another thing to be aware. So this was just a funny experiment we've done. And this actually brought us a couple of more questions. So maybe we could design this task differently. Maybe some other crowdsourcing tasks should be better. And I think this was the important one, how to deal with the gray area between good and normal answer. So maybe if a joke is funny, but someone tells us it's not funny at all, like gives us an answer absolutely on the other side of the spectrum, it should not be treated as if it was the answer that is kind of closer to the correct one. So that brought us think about it as well. And this is the last case study that I have prepared for you. And this is translation. So we're leaving the chatbot area for a bit. And we focus on the translation. So translation is definitely an NLP task. And we have our input is a text and our output is a text as well, just in a different language. So I put 3 different texts here, same text actually translated in the 3 different languages. So I love surfing. In Spanish, is me encanta surfear. In French, is j'aime le surf. And in Polish, is kocham surfować. So basically, in translation, this is what we need to do. We need to go from left to right. And this is the traditional pipeline that have been used in crowdsourcing projects for such tasks of translation. So it would usually consist of 3 projects. We have at the beginning this project 0 that we call it language proficiency. So we allowing again a lot of people to solve our tasks, but hey, we actually, if they say they speak French, I need to check if they speak French. So this is this level. Then there is project 1. This is actual translation project. So they have a text and they have to output a text in a different language. And then we have this project 2, which is validation. So we, again, only want people who speak French here, but basically we want them to read the original text, then the French text, and see if those actually are the good translations. And this is actually where a lot of things are found in this last phase. And if this last phase is not met, basically the same task has to be redone again. So the loop actually goes back to the project 1. And again, how we will measure performance. So this is something you've seen from the slides from audio transcription. We can use here, again, gold standards and metrics such as blue, meteor, word error rate, rouge. I think guys who work with NLP, you know they're not perfect, but I don't know if we have anything better. And then actually there are additional problems here because we did not have it in speech transcription. Does it sound natural or is it grammatically correct? So sometimes we do a translation, but it actually might not meet this criteria. So this part could be done with human evaluation again, creating different projects. So instead of having this last project asking if this is correct, maybe you could add also this type of questions there. And there are actually 3 different types of evaluation we use in crowdsourcing, and it's pointwise, listwise, and pairwise. And actually, so they all have pros and cons, and I'm going to tell you about them now. And this is an example of pointwise translation. So we have just the source text, and then we have to translate this text into a different language. And this is called pointwise because there's just one translation and it's easy to obtain. This is probably something, if you think about translation, this is how you would imagine this task to look like a normal person. It would imagine it probably like this, but it has low resolution. So basically on one page, one person, we can do only one translation. And so by low resolution, I mean, sorry, I think actually I think I missed one important thing, and sorry guys, I think I jumped myself. So I'm not talking now about only translation. Actually, here I did talk about translation, but now I'm focusing on this last part, which is the validation. So basically, we want to ask the person if this is correct. I think maybe I missed this point, and I'm gonna go back to this question. So the low resolution here means I have the source text and the translation. I have only one translation that I'm evaluating at one time. And you're gonna see the contrast now, because, for example, in listwise translation, I would have several options. So I would have I would be evaluating 3 different translation systems. So I would have one translation then second translation, and then the third translation, and maybe fourth translation, that depending on how many they are. And what I would ask the users would be, hey guys, order those. Which one is the best here? Does it make sense? Exactly, because we only evaluating one translation system at the moment, whereas here in one task we can evaluate. In this picture we can see three. We see three, but in reality you could have maybe 5, and so basically you would know which system is better than the other one by ordering those lists. But so actually the con of this, the pro of this is actually higher resolution. It's very useful for training machine learning algorithms. And the performer has all available context. So exactly, again, the resolution that we're talking about, he does not see one, but many, and can compare. But the cons are, it can be expensive because it's a harder task to do. And people can be inconsistent. So some people may order it differently than the other people, and it actually becomes a lot of trouble. So actually it comes to the last one, which is the pairwise translation. I think this is the most popular. Actually, we've been working with the guys who use it professionally for machine translating system, and they did use, they were the most happy with this pairwise comparison. So we have only 2 translations, and we say which one is better. So that way we basically can we can just decide between 2. And if we have more systems to evaluate, we create more pairs. Basically, this is something that basically mixes the 2 previous one, and I think works best in practice. So usually those are consistent because this is really easy to decide which one is better or worse. It still can be quite expensive. So imagine if you have many systems, there will be a lot of pairs. And it's a relative signal. So, okay, if they are 2 really bad ones, like, okay, they will choose which one is worse, but maybe they're still bad. So it's relative. And again, but as I say, every method has its pros and cons. And also the pairwise translation, the question comes in aggregation of results. So imagine you have created this many pairs, and you know in which pair the translation is better. You need to somehow aggregate it. And there is a Bradley Terry model. I don't know if you've heard about it. I don't know the details about the implementation, but this is something that actually is very common for this type of pairwise tasks. And you can actually, if you use Python, use the implementation that is in Python and aggregate the results. So actually it will, as a final result, you will know which system is better. And we've been actually working in evaluating such a systems for, I think it's the most famous conference in machine translation, and people come and show their new translation system, and we were given the task to evaluate some of them using Toloka. This is actually the interface, how it looked like. So we had a source text, and then on the right-hand side, we had the translation, and we actually had more translations. And it's not pairwise comparison that we did, but actually each translation, you had to decide how good it is, and you could slide this slider here. So just to give you an idea how the whole pipeline looked like. So at the beginning, in order to get participants on such a project, they had to pass a language test. Once they passed a language test, they were allowed on the exam. So exam is actually something that was unlocking the participation in our projects. Once they were on the projects, they were completing these evaluation tasks I have shown you. Also, during this process, we were constantly checking if they are doing it well. So if somehow their quality control would decrease, so we had some control tasks, we would actually ban them from the project for a while and maybe require them to pass a language or exam test again. So this is what was the pipeline that we did. And I think we translated a lot of languages. So there were some more common languages, like maybe German to English, but there were some really weird ones. Well, weird maybe for me. So I don't know the last language, Xhosa. I don't know if I'm pronouncing it well, but for example, they were translating this language to Zulu. So something, again, if you're working with crowdsourcing, you have to think that you need to find participants that speak those languages and both pairs. So sometimes it can be a hard task. And I think here I also added an exam that we were using. So if you work in a field like this, you can have a look. In order you want to replicate this. This is actually what you see. This is what was the exam. And I think they had to do some mathematical computation here and understand what are the shapes of figures. So basically, if they can solve this task, we believe that they speak this language. And yeah, that was the end of this example. And I wanted now to tell you at the end, just to wrap up things that about the automation of those processes. So in my opinion, and this is from our own practice, that we have found out, it's usually good to design user interface and instructions using GUI setup. And why? Because basically you want to see the interface. You want to play with it. If you have need to stop the recording, start the recording, you want to use those buttons. You basically, it's kind of, it can be done via code, but it's hard. So usually we recommend to set it up manually. But then the rest, you need to automate everything that is possible. So usually you want to have things like SDKs, APIs. So you want to control filtering performance, starting and stopping pools of performers, and gathering the results using code. This is just because it's practical, it's reusable, and I think those are the best practices. And actually, this is when, if you're creating these NLP products, this is when you can use your crowd basically as another computing cluster. And if you, any actually machine learning product, if you can gather data, label data very quickly, you have a competitive advantage for people who do it slowly. So you can build more models, you can practice more, you can see what works, what does not. And basically, this is because if your things are automated, they're just much faster. And this is just to give you some code examples. So with Toloka, we have the SDK, we have the API. I think we have Java SDK. But the most popular is the Python one. And I just gave 2 examples here. So at the beginning, we just open a training pool, and then we open a classification pool. So once I hit those buttons, basically people are allowed to do my tasks. I can implement maybe some automatic stops, etc. And then another example, the other one is actually aggregating results. So I have sent my task to many people, and I want to gather those results to a data frame. So this is basically what this code shows here. And that was the last thing that I wanted to tell you about today. So let me give a quick summary here. So natural language processing, we talked about many different tasks, many different NLP products, and they all require large amounts of data, text data, recordings, image data, as we mentioned as well. And another thing that we concluded, that evaluation of NLP tasks is hard. We talked about many different scores that are available, but I think this is still not a solved problem in NLP. That's why human evaluation is actually really important. And the last point is that crowdsourcing can be an effective technique to gather and annotate data. And I added this word at scale because it is a very scalable approach, unlike some other ones. And this is what I have added here. So actually, Toloka gives you a promo code. It's Data Science Toloka, if you want to try it for yourself. And if you actually want to get advantage of this promo code, you can go to our website, toloka.ai, click on Start Now, get labeled data, and register as a click on the blue part. This is, you register as a person who will be giving task. You don't want to register as an annotator, because if you want to try it for machine learning. And if you put then this code, I think you will gonna get $30 or something like this to do your own annotation. And also, we have our community. So this is a code. If you would like to join the community, learn more about crowdsourcing, crowdsourcing for NLP, you can scan this code. I usually hang out there, and you can also ask me questions there. And I think you can ask me much more questions now as well. Thank you. Thank you for listening. Yep.
Thanks so much. That's very good. One thing I was wondering is, during your evaluation process, you'll have translators who want to know better. Is there a way in which you are currently planning to, or already using, like, oh, this person is an expert, this is a 5-star person, let's, in certain cases, have them as a lead and have less numbers of comparisons for their work?
Certainly, we do something like this to some extent. So what we allow in Toloka, we assign skills to each performer. And each performer could have, for example, a language skill. And based on some control task, we can update this skill all the time. And we have in Toloka some kind of global skills for everyone. But you, as a machine learning engineer who posts the task, can actually create your own skill, because what we actually have found out that a lot of people require different, there is not the same projects in Toloka. Pretty much every project is different. But the same project requires constant flow of people. Like if they do a small change in machine learning algorithm, they actually need to run it again. So basically, if you actually create a skill for performers, you can use this skill forever, basically to pay him more money, or because he's doing well. So we use something called dynamic pricing. And this is something that Toloka allows, and allows for this infrastructure, but it's up to the user to implement it. We can show you examples and everything, how it can be done. Exactly. Exactly. And actually what you're saying, dynamic pricing, from our own experience, it works really well. And it's very also, if you ever gonna use it, it's very important to mention it in instructions that if they give better results, they will be paid more. Yeah. Okay, so active learning. I don't know if we've been working with projects with active learning, but how would you see it? How would you, I mean, how would you describe this active learning project?
One of the issues is
might start giving a lot of big A comments, and then whatever your model will be very good at understanding what something is like, but not so good at yes.
Okay.
Learning is about maybe have some kind of model in the background that will see, we're able to say, oh, I'm not very confident about those comments that maybe you receive, and therefore I'm going to provide those to whoever the annotator or whoever is making.
Yeah.
So it's like providing what the model will be the least confident. If it works for dates.
Yeah.
Classifies.
Yeah. I mean, great question. Actually, we do this. I never called it active learning. We actually call it often human in the loop. But I don't know if actually it falls under this active learning label or not. But we actually do it, and we do it for some of our clients. We have a model that actually is already pre-trained on the data. We actually use it to aid our labeling process, and maybe only some of the labels that the model is not very confident about, we only send to labelers. And also, we do it, but this is not our standard thing to do. We usually use human labels, but actually, this example is very common what our clients do. So actually, we've been working with one company that is moderating pretty much live data. So this is a platform similar to Medium, where actually a user can post content, and it can be videos, it can be text, it can be pictures, so a lot of stuff. And obviously, because it's user posted content, it needs to be moderated for things like sexual content or an inappropriate content or things like this. And because this data changes so fast, let's say right now we are talking about world economic crisis, then something changes. Those models, the pre-trained machine learning models, do really bad really quickly. So exactly this is what they do. When they see that the model is not very confident about the labels, they send it to humans. And also, if they see that it's degrading all the time, they actually not only send those labels, but they kind of send a new bunch of data to get it all relabeled again. So this is very, very common, actually, example. Yeah, so again, I kind of think now about data augmentation. So I think an NLP, I don't know if you've been working with it, maybe, yeah? Okay, how do you do it? I'm familiar with data augmentation, something like in computer vision. So let's say we have a picture and we change it, but with NLP, I don't know, how do you, yeah. I don't know, maybe there are people working on it, but I just say it hard. So like how I would do it, imagine I have a sentence, it's a positive sentence. How could I do an augmentation? Maybe I change the order of the words. It should have still the same sentiment, but I think it's incorrect in NLP case because the order matters. So I don't know, but I would have to research it. Okay, good. Okay. That's a cool one. Uh-huh. Okay. Uh-huh. Yeah. A good one, yes. We actually haven't been doing it, so yeah. Yeah, but this specific, I like the idea, like finding synonyms, and yeah, we just didn't like. I haven't heard a case like this, but yeah, yeah.
Where people are trying to label data that's knowledge or domain specific, with the kind of intentions that people kind of upload specific scenarios that they want to upload. Do you have enough data on specific industries or specific problems that you don't require the human intervention? You can just have a model run over the top of it, or does every scenario require?
Yes and no, and I'm gonna tell you why. We actually, so first of all, we can't use our data that our clients label to build our own models. So if it would be, that would be usually our client who builds this model, etc. But actually, there was some data that we actually gathered, and we have like it's our data, and we actually built some models that solve different tasks. And we're actually building a catalog of those right now. So just to give you an idea, we have a model that does sentiment analysis. And the models for sentiment analysis, they are available everywhere. But you want your model to be trained on a specific domain. So for example, for us, let's say search relevance. So we provide such a model. And we are actually right now working on different types of models that we are developing and we will be offering to our clients. Yeah.
I guess a related question to like scale the evaluation. You mentioned the WER metric to look at like how accurate are you looking at individual annotator, how accurate they are using them?
Exactly.
And if that's the case, then you get like in the beginning of your annotation that you do it on.
A good one. I think it should be done all the time. At least, and again, everybody designs your own pipeline, but you want to control quality throughout the whole project. So I would suggest that actually every task they complete, it should be that you should check them for quality, or every control task they hit, it actually should trigger their computation. And this is actually how Toloka is implemented. It's by default that it does it that way.
In that case, because I guess the denominator is sort of like you have some staff in Toloka to give them the sentence, then do they have to keep turning out like correct examples?
Exactly. You are totally right. This is again, so by kind of outsourcing our data annotation, we basically limit amount of work we do, but we still need to annotate this very small data that actually will be used for checking. But we've been experimenting with those things. So this, up till a week ago, I think usually a person who starts project on Toloka, they would have to upload their own control tasks. But I think a week ago, we actually implemented a feature that we can create those control tasks for you. So that I could answer your questions, that normally in a normal flow, yes, you have to create them. But I think very soon, we already released it, you actually don't. We will create it for you.
Oh, but you don't automate it like
This is a good one. I don't know how it's done in the background. It might be that actually our experts create another project that maybe uses these very knowledgeable performers, only the best ones, to create those control tasks.
And what does the WER stand for?
WER?
Yeah.
Word error rate.
Oh, whatever. And I guess a second question would be like more abstract when you're talking about like humor and you think it worked by like having people evaluate whether a joke is funny or not. What do you mean by it worked? Because you said at one slide that you are having a lot of annotators to like tell you whether they think a joke is funny or not, and you say that it worked by like having people evaluate
How do we know that it worked?
And what do you mean by it?
Yeah, I think we believe that the results were pretty consistent. That actually they kind of represented of what we were looking for. It's again I would say it's again our subjective. It's not an objective evaluation here. Yeah, we did not use a metric or anything like this here.
But you think that sort of evaluation chatbot helped your attitude?
Yeah. Yeah, I'm running actually another experiment, which actually I ask people to give opinion as well, and I'm running it in Toloka right now. So maybe I will have some more results in 2 months, because I think I will be working on this project more in a few these months. Yeah. Yeah, certainly, and that's why I think this aspect of crowd being everywhere is very important. I think it kind of brings another aspect here of bias in machine learning. So you would like your data to come from these different backgrounds, ideally, and I think Toloka allows you to do it. Obviously, you don't have to follow the rules. You can choose people from one country, but you have the tool actually to do it and try to create algorithms that actually don't have such biases in them. No, we don't have such a word. No.
In your case, you probably have a very large pool, might have more diversity, but how do you track, biases and for labeling? And how do you track that to make sure that the least amount of bias?
Okay, so again, we kind of do recommendations, and we give access to people all over the world, and they can basically, with our tools, maybe at least we try to give you enough so you can implement it. So imagine if you would like to include people of different ages, maybe you could, and basically how I would do it in Toloka, for example, instead of creating one project, maybe I would create 10 different projects, and I would have in one people between 20 and 30, in one people 30 and 40, etc. Maybe not projects, we call them pools. They are actually, so pools are projects. They have the same project instruction and project setup, they just different bunch of people labeling it. This is basically a pool. So you would just create different pool and maybe allow only 10 people on each pool, and then making sure that you have 10 people from each age background. And obviously we cannot track all the features of the people. We have some basic information such as the country they're from, their age, I think their location. I think the location can be get, but obviously we don't also have very detailed information. Yeah. Yeah, thank you. Let me know if there are any questions from. Yeah. Okay, perfect.
Okay, so we're actually going to have a
Yeah.
see if it continues during the question. Specific need to do transcribing.